Hello class 11. In our last class we discussed about the different physical parameters like mass, weight, volume, density, its units, and then after that we discuss about the different scales of temperature, degree Fahrenheit, degree Celsius, and Kelvin scale, and we have also seen the conversion of one temperature to the other. So now today we discuss about Dalton's atomic theory. Remember that this thing you have already studied in class 8 and class 9 if you remember in the chapter atomic structure. Okay, once again, just to have an idea about the atom, John Dalton proposed his theory based on his experiment and observations based on the atom. According to his first point, he mentioned that all matter consists of very small and indivisible particles called atoms. So all the matters are composed of a very small and indivisible particle that we call it as atom. Next, second point is atoms of the same element are identical in all respect. So if we take the atoms of the same element, then it should be same in all respect. That means it should have same mass, it should have same shape, same weight. Okay, all these things should be same. But this has been proven wrong. This second point has been proven wrong because it could not explain the idea about the isotopes, because as we know that isotopes are the atoms of the same element having same atomic number but different mass number. If we are taking the same element, then why should they have the different mass? So this could not be explained by Dalton's atomic theory. That was his drawback. The third point is atoms of different elements differ in properties and weight. So if you take atoms of different elements, they should be totally different. They should have different properties, they should have different weight. But here also it has got a certain drawback because it could not explain the idea of isobars. As we know that isobars are the atoms having same mass number but different atomic number. So if you are taking the elements of different, if you are taking the atoms of different elements, then if their masses are different, then how, if their masses are same and their atomic number are different, how it will verify this point? So that was also his drawback. So these 2 points has got drawback. Next is atoms can neither be created nor be destroyed. As we know that atoms can neither be created nor destroyed, but this also proven to be wrong because as we know that during nuclear reaction, in nuclear fission and nuclear fusion reaction, atoms gets destroyed and some other atoms are created. So this also could not be explained by it. Next, atoms of an element combine with atoms of another element in a simple ratio to form molecules of compound. This is true because when atom combines with each other to form a compound, it always combine in a simple ratio. Say for example, in water molecule, 2 atoms of hydrogen combines with 1 atom of oxygen. And the last point is atoms are the smallest unit of matter that can take part in a chemical reaction. So it is the atom which takes part in a chemical reaction. That's also true. So these are the main postulates of Dalton's atomic theory. Next, we'll study about laws of chemical combinations. These are very, very important under this chapter. The combination of elements to form compounds is governed by the following correct is 6. Okay, 6 basic laws. They are law of conservation of mass, law of definite proportion, law of multiple proportions, law of reciprocal proportions, and Gay-Lussac's law of gaseous volume and Avogadro's law. Remember that this law of conservation of mass you have already studied. Then Gay-Lussac's law of gaseous volume you have studied in class 10 under the chapter mole concept. Avogadro's law also you have studied there only. So over here we have got this 3 law new for you. Okay, so once again we'll discuss all these law one by one along with their explanation. So first I'm going to see law of conservation of mass. Okay, law of conservation of mass. So in law of conservation of mass states that matter can neither be created nor destroyed in chemical or physical changes. So when you carried out any physical or chemical changes, matter is neither created nor destroyed. Say for example, we'll try to prove this with an experiment. What we have done is we have taken two solutions, okay, two solutions in two beakers. In one we can take it as silver nitrate, and in another sodium chloride. Okay, both of them are colorless solution. Okay, both of them are a colorless solution, and we take the weight of them when we have not mixed the two solutions. So say for example, the weight is coming as 92.95 gram. Okay, now what we'll do is we'll mix it. That means one of the contained solution will add to the other. So after adding it, you'll observe some changes over there. You'll find white precipitate when sodium chloride is added to silver nitrate. A sodium chloride is formed, a silver chloride is formed, which is white precipitate. You can see white precipitate and the chemical reaction has taken place. Now you take the weight of that both container. You'll find the weight remains the same. That means over here, mass is neither creating nor destroyed. That means it remains conserved. This is law of conservation of mass. Okay. Next we have got law of definite proportions, or we also call it as law of constant composition. Okay, the law states that a chemical compound contains exactly the same proportion of element by mass. That means when any chemical compound is formed, the masses of the element remains the same. The ratio or the same proportions will be found in all the compound that is formed from the same elements. Say for example, irrespective of the source, a given compound is always contain the same elements in the same proportion. Say for example, water. You consider water. Water can be obtained from any source: river water, sea water, tap water, spring water. Okay. Now, when you see the compound water, okay, don't see its source. Now, this water is always composed of hydrogen and oxygen combined together in the ratio 1:8 by weight. Now let us see why it is 1:8. Water, we have got H2O, so hydrogen and oxygen, we write it 1 is the atomic or mass number of hydrogen, and we have got 2, so we multiplied by 2. 1 is 2 into 16 is the atomic mass of oxygen into 1, because we have got 1. So the ratios come as 2:16. When you cancel it, it becomes 1:8. That means in any compound of water, whether you take it from anywhere, it has always the hydrogen and oxygen combined in the ratio of 1:8 by weight. Okay, this is law of definite proportions. Now today's assignment, that will be assignment number 3. Question number 1, write the main postulates of Dalton's atomic theory. Okay. Question number 2, differentiate between isotopes and isobars. You can write down the definition and give the examples. Question number 3, state the law of conservation of mass. And question number 4, explain law of definite proportions with an example. So complete this assignment and send it in my mail.